In this class, we discuss about the solution of an important problem of tensor calculus. And the problem is, if a PQR, XP, XQ, XR, this is given by 0 for all values of the independent variable which are given by x1, x2 to xn. And a PQRs are constant. This is given by a PQR, this is constant. Okay. Then we have to prove the result that a KJR plus a JKR plus a IKJ plus and so on, this is equal to 0. Okay. This is very simple problem, and here we use the concept of Kronecker delta. What is the definition of Kronecker delta? We define the Kronecker delta or Kronecker symbol as delta Ij, which is equal to 1 for I equal to j, and this is equal to 0 for I not equal to j. Okay, and Kronecker delta is also used in this way. If we differentiate the independent variable xi with respect to independent variable xj, then it is equal to 1. Clearly this is equal to 1 if I this is equal to j, and this is equal to 0 if I not equal to j, because xi and xj are both independent variable. Okay, so we write this as the Kronecker delta, this is ij. Okay, now here the given relation is, we first write the relation a PQR XP XQ XR, this is equal to 0, and this is named as 1. Now differentiate 1 with respect to xi. We first differentiate this relation with respect to xi, and getting the result as a PQR, because this is constant, it is also given, and we get the differentiation as del xp by del xi xq xr plus a PQR xp into del xq by del xi, and this is fixed, plus a PQR into xp into xq into del xr by del xi, this is equal to 0. Okay, and now we write this term and this term using the notation of Kronecker delta. We already defined the notation, and we get the result as a PQR into, this is delta pi xq xr, this is a PQR xp, this is delta, we write first the Kronecker delta, this is delta qi xp xr plus a PQR into delta ri xp xq, this is equal to 0. Okay, and clearly here p and p here also present in the suffix, and here p present in prefix, that is here p present in superscript and p present in subscript. So this is the dummy index. Okay, and we changing the dummy index p to I. Here also q be the dummy index, here we change q to I, and here r be the dummy index, so we change r to I, and the result we write as a IQR into delta II we write, because dummy index p is replaced by I, and xq and xr as usual in the previous line. And similarly we get a PIR, and this is delta II xp xr plus this is a PQI, this is delta II xp xq, this is equal to 0. Okay, now delta II and this all of them are 1. So we get the relation as AIQR XQ XR plus APIR XP XI plus APQI XP XQ. This is equal to 0. Now we differentiate this relation with respect to xj, right? We differentiate this relation with respect to xj and we get 6 term here, because from here we get 2 term, from here we get also 2 term, and similarly from here we get 2 term, and this implies AIQR del xq by del xj into xr fixed, and from this we get the second term as AIQR xq is fixed and del xr by del xi. Okay, sorry, this is not I, this is j, and similarly we differentiate this term and we get the result as, differentiating with respect to xj we get this line, and putting all the differentiation, this 6 differentiation with the symbol of Kronecker delta here, we get the last line here. Okay, as usual, as above. Now here also it is clear that q be the dummy suffix, so we change the dummy suffix q by the j, and here the dummy suffix r is replaced by j. Here the dummy suffix p is replaced by j, and all the dummy suffix are replaced by j in this line, and we get the result as AIJR XR, because delta jj this is equal to 1. Okay, and we directly write this line as AIQJ into XQ plus this is dummy suffix AJIR into XR plus this is R dummy suffix, so APIJ into XP plus this is JQI into XQ plus this is APJI into XP, this is equal to 0. Okay, we get the relation as this. Now we again differentiate this relation with respect to xk, and getting the result as AIJR del xr by del xk plus AIQJ del xq by del xk, and so on, and also we put this value as AIJR into delta rk. Okay, and the second term is AIQJ into delta qk, and so on. We write similar way in 2 lines. Okay, now here we also change the dummy suffix r by k, q by k, and so on. We get our required result. Now by changing the dummy suffix as similar as above, we get this result, and we write the result by arranging this term as given in our proof. Okay, so very easily we can prove this result. This is very important proof of tensor calculus. Okay, thank you for watching.